Alright guys, we're going to be solving another question from the chapter 4 of engineering mechanics by Meriam, and we have this bumper jack that is designed to support a 4,000 Newton force downward, which is applying at point D, and the question is telling us to begin with the free body diagram of BCD, or this member in here, and we need to determine the force supported by the roller C, noting that the roller B does not contact the vertical column. So this point is not contacting the column. So as the question is saying, we're going to start with the free body diagram of this member. And we have a pin at point A, which means we have two component AX, AY. Let's just call our X and Y in here. And we have a roller at point C, meaning it can freely move along y-axis, so we don't consider any component in y direction, just consider one single force, C or Cx, as our force. Again, we do not consider any friction between point C and the column, so that's why we don't consider any y component. And we have the 4,000 Newton force at point D, and that's pretty much it. We are in equilibrium. We have three equations: sum of all forces in x equals 0, sum of all forces in y equals 0, and we have one moment equation. So what the question is asking is the force at point C, or the roller force, which we call it Cx. And since we have the most unknowns at point A, we can just start with our moment equation about point A, counterclockwise positive as always. So we're going to have the moment of the 4,000, which is going to be a clockwise moment, so negative 4,000. So for finding that the distance that we have in here, I'm just going to clean up AY. So we are interested, as we talked about the 2D shortcut that we have for moment, we're going to find the distance from A to the line of action of the force D, and we're interested in the vertical distance. So this will be our distance, which is 400 plus 150. So this will be 550 millimeters. And the next one would be our force at C. This one's going to be counterclockwise, so it will be a positive moment Cx times, same concept, vertical distance from A to the line of action, which if I look at it, it will be 240, which is here, plus 100. So that's going to be 340 equals 0. I didn't do any unit conversion because basically it's dividing each of these by 1,000 to get it in meter, which won't make any difference in our equation. So Cx would be pretty easy. You just have to multiply 4,000 by 55 and divide that by 34. These two will be canceled out. So let's see what we get. 4,000 times 55 divided by 34. And this is going to give us 6470.6. And the unit will be in newtons. And that would be the final answer for this question. Hope everything was clear. Let me know if you guys have any questions. You guys take care. I'll see you in the next video. Have a good one.